Hello again, welcome back. In the last video you watched how you could multiply polynomials with other polynomials or a monomial with polynomials. So now we're going to show you a special products of polynomials. These patterns you may want to memorize because they make multiplying kind of easy. The first two patterns, it's actually one pattern, square of a binomial, where we have a plus b is squared and the other pattern is a minus b squared. So here's how the pattern works. The first one says a plus b times a plus b. So if we use our multiplication through distributing here, we have a times a, which is going to give us a squared, and then a times b is going to give us a positive ab. And then we come back and we do b times a, which is going to give us an ab again, and then b times b, which is going to give us a positive b squared. So as we start to combine our like terms here, you'll see we have nothing to combine with the a squared, so we bring the a squared down, but we have ab plus ab. Basically we have ab times 2. So we're going to add to ab, and I don't have anything to combine with my b squared, so that just attaches at the end. So whenever you have an a plus b squared like this, you can always use this pattern where you take the first term and square it, the last term and square it, second term and square it, and then the first and second term multiply together and then just double it or times it by 2. And it always has a plus in between. So we'll show this next one here. This one means a minus b times a minus b. And we're going to distribute here. A times a is going to give us a squared. A times a negative b is going to give us negative or minus ab. And then negative b times a is going to give us negative or minus ab. And then negative b times negative b is going to give us a positive b squared. So as we start to combine our like terms, we see we have no other a squared, so we bring that one down. We don't have any other b squared, so we're going to bring that one down. I'm going to make some space here. But in the middle, we simply have an ab. Again, they're both negative, and I have 2 of them, so we're going to do a minus 2 times ab. And that becomes the pattern for a minus b squared. Let's see how this works as an example. Rather than going through that whole distributing process, the pattern here allows us to shortcut it. So we're going to take this first term, we're going to call that our a term, and then we'll call this second one our b term. So our answer should be the 2x, which is a squared, plus 2 times a, which is 2x, times b, which is 1, plus b squared, which is 1 to the second power. And that's the pattern. All we got to do is square and multiply everything out. So this first one here is going to give us 4x squared when we square it. The middle term is 2 times 2 is 4. 4 times 1 is 4. So positive 4x. And then the last one is just 1 squared, so positive 1. So taking a number and squaring itself, a binomial and squaring itself, is easy as this. Example 2, same thing, 3m plus n squared. This is our a term, this is our b term. So we're going to take our 3m, square it, plus 2 times our a term, which is 3m, times our b term, which is n. And then at the end, we're going to take our b term and square it. So the first one is going to give us 3m squared, which is 9m squared, plus 2 times 3 times the 1 will give us 6mn, plus n to the second power is just n squared. So this entire thing right here becomes 9m squared plus 6mn plus n squared. An example where we have a minus instead. We're going to call this our a term, and this is our b term, and it is a negative. So it's going to be 4x squared plus, and the pattern is always, actually this is going to be a minus, minus, and our pattern is to always put a times 2 in there. So 2, 4, x is our a, y is our b, and then a plus y squared. And we're going to square our first one. 4x to the second power is going to give us 16x squared. 2 times 4 times 1 is negative 8xy. And then we have a plus y squared at the end. And it's really that easy. Another example where we have two variables in it. This is a, this is b. So 3m squared minus, because of the minus term, our second term is minus 2 times 3m times 7n, and then plus 7n squared. Now you'll notice at the end there we actually have a 7 inside there, so it won't just be the number or the variable squared. Okay, so let's do this first one. 3m squared is going to give us 9m squared minus 2 times 3 is 6. 6 times 7 will give us 42mn plus, and then 7n squared is going to give us 49n to the second power. The last one is a sum and difference pattern. Now it's very important to understand that you have to have opposite signs here, and the first term has to be exactly the same and the second term has to be exactly the same. And the way that this pattern works out is we do a times a, which gives us a squared, a times negative b, which will give us a negative ab, and then a positive b times a will give us a positive ab, and then a positive times a negative b will give us a negative b squared. And right away you'll notice we have a positive and negative ab in the middle, which basically just cancel each other out. So when we move those out of the way, we end up with an a squared minus b squared. So instead of having a trinomial, we have a binomial. For the first term is squared and the last term is squared, and in this difference of squares, sum and difference is always a minus in between, never a plus. An example here. First two are the same, last two are the same, the signs in the middle are different, so all we got to do is take the first term, square it, minus the second term, square it, and x to the second power is just going to give you x squared, minus 3y to the second power is going to give you 9y squared, and that's your answer from multiplying these two binomials together.